So we continue with trigonometry, and the question is still calculate the length of x, where x is a side in a right angle triangle. And we have learned two strategies, Pythagoras, and Pythagoras we can use when we know two sides and we want to calculate the third one. A squared plus b squared equals c squared, the hypotenuse squared. However, many occasions they give us a right angle triangle, but they now only give us one side and an angle. But we have learned we can use trigonometry instead. So even before I'm going to start calculating anything, I'm just going to write down those ratios. TOA, Ka, So. And perhaps you have learned a different order, Ka, Toa, So, or So, Ka, Toa. You do whatever order you've learned. It really doesn't matter. There are not a lot of things in math you really have to remember. But this is just one of them. And trust me, if you give it some attention, 20 years later, all of a sudden I was a math teacher, and all of a sudden I was teaching trigonometry in front of a class, and I could instantly produce Toa, Ka, So, because if you really have to remember something important, you will. So trust me, if you give it some attention and you try a lot of questions, you will remember to write it down every time correctly. Anyway, I told myself, well, I'm going to really physically stand in that corner. They gave me this corner 60 degrees. I'm going to stand there. I'm standing in that corner inside my triangle, and I'm going to find out which sides do I know. We have a hypotenuse, we have opposite and adjacent sides. Now the hypotenuse is always the same, on the other side of the 90-degree angle. So I know the hypotenuse, and I know, or I want to find out, I should say, the adjacent. I'm touching that one when I'm standing in this corner, the adjacent. So adjacent and hypotenuse, and I have a look, and that is the cosine. So now I know which ratio to use. So I say cosine of 60 degrees equals the adjacent over the hypotenuse. So that is x over 7. You see how it took me about 30 seconds before I actually wrote something down on paper, because I am analyzing the question and I'm making sure that I don't make any silly mistakes. I really want to be in control. I want to be understanding what I'm doing. And to make sure you do things properly, you just analyze the situation before you just randomly start, or instead of you just randomly starting writing things down. Anyway, rearrange the formula. So that means what is the value of x, excuse me, times both sides by 7. Let's do that. I had to get rid of that fraction. Alright, what do we get? Well, x on this side and 7 times the cosine of 60 degrees. And again, you won't hear me say this very oftenly, but a calculator sometimes really is your friend, because you do not have to know all these ratios by heart. Cos 60 equals, your calculator tells you that's 0.5. In a few years time you'll know why, but for now that is enough. 0.5 times 7, and that equals 3.5. Fantastic. So x equals 3.5. So actually for this right angle triangle we didn't need Pythagoras to find our missing length. We used trigonometry. We used the cosine, which is based upon the principle of similar triangles. We also used the cosine to find x. And by the way, now knowing x, I could also find the third side with Pythagoras, or again with trigonometry. But we're not going to do that now. We're going to move on to the next question, because I have one more sheet after this one. And again, right angle triangle. Every time I'm telling myself the same things. Right angle triangle, that's important. Pythagoras perhaps, hypotenuse. I know an A, but I don't know the B. But I do know an angle. So trigonometry, standing in my angle. I'm standing there and I see the opposite. I see the opposite there, and the hypotenuse is the hypotenuse. Opposite hypotenuse, alright, that is the sine. So the sine of 25 degrees is the opposite over the hypotenuse, 3 over x. Now I gotta rearrange the formula, and I gotta do one extra step compared to the previous question. Because to get rid of my fraction here, I times both sides by x. Yeah. Then I get x, the sine of 25 degrees, x times the sine of 25 degrees equals 3. And then in order to isolate x, I have to divide both sides by the sine of 25 degrees. Yeah, now make sure that you understand what I'm doing now, that you know how to rearrange a formula, that you are very comfortable with solving equations. There was a reason why in Key Stage 3 your teacher was emphasizing on that so much, because now you are still using that even doing trigonometry. X equals 3 over the sine of 25. Fantastic. So calculator, thank you very much. 3 divided by the sine of 25, and that equals 7.0986044749. Now, we never want to know all these decimals in our final answer. Of course, when you are still calculating, in between your calculations, you can never round. You only do that at the end, when you have your final answer. Let me put it here, because our final answer we want in 3 significant figures. 7.09, that's my third one. But does it stay in 9 or does it go up? That depends on the next one. It's an 8, so it does go up. So the 9 then becomes a 10. So 7.10. Do not forget to write down that 0 there at the end. That is my third significant figure. Yeah, and it's important that you write it. 7.10 in this particular case is not the same as 7.1, although you might think so. Anyway, that's a different discussion. I just want to show you a last thing here. I have quickly sketched 2 triangles. They're congruent, they're exactly the same. Congruent triangles, exactly the same. The lengths are the same, the angles are the same. Yeah, so exactly the same shapes, congruent shapes. And in order to find x, I just want to show you that what we are doing is really not hocus pocus, abracadabra. It really does make sense. If I stand in my angle of 40 degrees here, and sorry, before I start, I really should write down toa ka so. Every time I write it down. And I want to find out my opposite, the opposite on the other side, and I know my hypotenuse. Opposite hypotenuse, that's my sine. So the sine of 40 degrees equals x over 12. So x equals 12 times the sine of 40 degrees. You see, if you gain experience, you are able to do these things a little bit quicker than perhaps when you are starting. Anyway, the sine of 14 equals times 12 equals, and to 3 significant figures, that is 7.71. So x is 7.71. Well, that is fantastic. Now I just want to show you that it really is 7.71. So that's why I drew this one, because I'm going to approach it a little bit differently. What if I stand in that corner? Now, considering it's a right angle triangle, you have 180 degrees to divide over your 3 internal angles, 90 degrees, 40 degrees, that makes that third angle 50 degrees. Hopefully you realize that. And if I now stand in that angle of 50 degrees, I can even turn it around perhaps if that helps me, 50 degrees, then, well, they give to me my hypotenuse, but now I want to find out my adjacent. Where here I want to find out my opposite, and they give me my hypotenuse. If I stand in my 50 degree angle, I want to find out my adjacent, and they give me the hypotenuse. Now, adjacent and hypotenuse, that's the cosine. So the cosine of 50 degrees, in this particular case, equals my adjacent, x, over the hypotenuse, 12. Now x didn't change, and I said it was 7.71, so this now should give me the answer of 7.71. Rearrange the formula, multiply both sides by 12 to get rid of that fraction. So 12 times the cosine of 50 degrees. So again, this now should give me the answer of 7.71 to 3 significant figures. And I hope you understand what I'm trying to do. Where again, I'll just quickly summarize that. Here I was doing the sine, that was my opposite x over the hypotenuse. And now here, x became my adjacent over the hypotenuse, so the cosine. Let me see if I get the same answer. The cosine of 50 equals times 12 equals, and to 3 significant figures, and it is just unbelievable, it gives me 7.71. So actually your teacher is not just telling you some things and it's completely irrelevant and it's actually not true. No, he's telling you things which are true always in any situation, as long as you have a right angle triangle. Yeah, they give you a length, they give you an angle, you can always calculate the third length. Doesn't matter in which angle you are standing, as long as you pick the correct ratio, yeah, and you take care to determine which sides you want to find out and the sides they give to you. Either the hypotenuse or the opposite or the adjacent. I wish you all the best and try to have some fun at the same time.